Hello, everyone. My name is Kashana Evans, and thank you for giving me a few minutes to walk you through the cybersecurity consideration of moving to the cloud, specifically using Amazon Web Services or AWS. As you know, cloud based systems have rapidly become the backbone of many industries due to their scalability, flexibility, and cost effectiveness. But as we embrace these benefits, cybersecurity must remain at the forefront of our strategy. Let's begin with the fundamental principles of cybersecurity: confidentiality, integrity, and availability, or the CIA triad. These principles are closely interconnected in AWS. Confidentiality is enforced through tools like identity and access management, which ensures users only access what they are authorized to. Integrity is maintained through services like AWS CloudTrail, which logs all account activity, allowing us to detect unauthorized changes. Availability is supported by the infrastructure's built-in redundancy and scalability. These principles guide the mechanisms AWS provide, like encryption at rest and in transit, automated patch management, and multi-factor authentication. To minimize risks, threats, and vulnerabilities, AWS recommends a shared responsibility model. That means AWS secures the physical infrastructure while we, as the customer, are responsible for securing our data, configurations, and access. To follow best practices, we'll enforce least privilege access, encrypt sensitive data, automate backups using AWS Backup, and regularly perform vulnerability scans with tools like Amazon Inspector. One of the simplest but most critical steps is to close unnecessary or unused ports. Open ports like SSH22 or RDP 3389 are often the first things attackers look for. With AWS, we can use security groups and network access control lists to allow only specific ports and IP addresses. For example, we can restrict administrative access to only our internal network or specific VPNs. This significantly reduces the cloud's attack surface. Now, let's talk about patch management. AWS offers services like AWS System Manager, Patch Manager, which allows us to automatically scan and install updates across our instances without interrupting operations. Timely patching is critical because delays expose us to vulnerability windows, the time between when a flaw is discovered and when it is fixed. Attackers often take advantage of this window, specifically in zero-day situations, where a flaw has been discovered and there's no fix available yet from the software provider. Having an automated system shortens this window and ensures we stay protected. Another key area is mobile device security. With the rise of BYOD, bring your own device, more employees are using personal phones and tablets to access cloud resources. AWS supports mobile device management, integrations, and enforces conditional access policies that block access from unsecured devices. AI is also playing a bigger role here. According to NIST SP 1800-22, artificial intelligence is helping detect risky behavior in mobile apps by learning normal usage patterns and flagging abnormalities in real time. This is specifically important to hybrid and remote settings. So what's next? AI will continue to reshape cloud security, specifically for mobile. Expect more behavior-based access controls, adaptive authentication, and real-time threat detection built right into cloud services. AWS is already integrating these capabilities into their services, giving us the tools to stay ahead of cyber threats. In conclusion, AWS offers a robust platform with the tools and support we need to build a secure, scalable environment. By leveraging AWS best practices and security mechanisms combined with strong internal governance, we can confidently manage our data and infrastructure in the cloud. Thank you again for your time.